Hello and welcome. Thank you for joining our webinar, where we will be discussing how Red Hat OpenShift enables DevSecOps platform choice. Today we'll be discussing how OpenShift's open source roots allow enterprises to choose DevSecOps platforms really based on their needs. And that's really important, and we'll get into why that is. Before we begin, if you aren't already following us on LinkedIn or Twitter, go ahead and follow us so you can stay up to date on the information that we're constantly publishing, our thoughts, things that we're seeing, trends, things like that. It's also a great way to get in touch with us. Also, this webinar will be available on our YouTube channel not long after we wrap up here. So a little bit about Excelno. We are a consulting company where we focus on really helping customers leverage IT to address challenges, add new capabilities, whatever it may be. It may be a combination. We look to do that very quickly and helping teams and companies enable themselves to go above what they currently can. And the role that I play is I'm a director and a co-founder, and my background is in IT consulting. I started on the development side, but throughout my career, I was exposed to the infrastructure side of things as well, and that got into cloud and a lot of other things. And then, really early on, I experienced the challenges with security. One being at the end of the SDLC, but also really a lack of automation, where a lot of things were done manually or through kind of homegrown scripts and things there. So I really have, if you will, those war wounds. That is, what is it like to really live in that and have to deal with that? And as things start to get automated, how does that free up resources? How does that allow teams and individuals to focus on more value add activities? So again, here at Excelno, we take our expertise and we help companies adopt DevSecOps and go into the cloud and cloud native. And while for some companies they start with DevOps, we work to help involve security into that. And we understand really the challenges and the changes required when adopting DevOps or DevSecOps. And more importantly, one of the things that we also do is when we're working with companies and our customers, we impart our knowledge through our mentoring model. And the reason we do that is that we understand and want to help companies avoid the challenges that maybe other companies have made. And again, our goal is to really help our customers get to their goal and their finish line as quickly as possible. And again, it's not, that might be the first goal or finish line, and there's always going to be another one. And so we want to, again, help impart our knowledge and prepare our customers for future success. So again, today we're going to be talking about how Red Hat OpenShift enables DevSecOps platform choice. Okay, so one of the three things we want to really cover today: what is DevSecOps? And we're also going to look at using OpenShift and Snyk, and then also leveraging OpenShift and Prisma Cloud. So what is, from Shannon Leitz, the co-author of the DevSecOps Manifesto, she states that the purpose and intent of DevSecOps is to build on the mindset that everyone is responsible for security, with the goal of safely distributing security decisions at speed and at scale to those who hold the highest level of context without sacrificing the safety required. How do we boil that down? So everyone that is involved throughout the SDLC has some form of responsibility for security, whether that's identifying it, educating, addressing it, whatever it may be. Everyone's responsible for it. And the goal of that is to distribute security decisions quickly to the various team members. Right? Again, who's going to educate on it? Who's going to find it? How is that found? Which we're going to talk about today. How does it get addressed? And then tracking that it's been released and the impact there. And again, we don't want to do things at speed without, while sacrificing the security that is required to do so. In other words, we don't want to try to implement security with a trade-off of removing security or making other sacrifices elsewhere. So the way that we look at it is that DevSecOps is a comprehensive approach to focusing on security during the building and running of software. Now, what I have here is what you traditionally see. You plan, you develop, you test, and you demo, and you kind of go round and round. That's usually between the development and the QA team as part of the life cycle of development. Now, When we bring in DevSecOps, right, we're going to create a culture where security is a shared responsibility throughout the IT lifecycle. And we find that DevSecOps mindset across all the teams is so important because of the emphasis on the need to build a foundation of security, right, into all of the DevOps initiatives. So if we take that and we compare that, what is typically done? So we talked about that traditional development piece. Well, then what happens? Well, there's usually a security team, let's say a security QA team. What they're doing is they're planning, they're scanning, they're testing, they're reporting, they give that information back over to the dev side of things. And usually, my experience and what I've seen is that happens at the end of right before a release. And what happens? Well, the business and wants things out the door by a certain period of time. And that's what the development team committed to. And they've been developing you right by a release window. And so now that the scan is done, there's other bugs and other things to address. And so some of the security stuff might be able to get in there, but they really got to hit the date. So a lot of the security issues aren't addressed. Application, whatever it is, gets released. Security issues get put into the backlog. That becomes technical debt. And what I've traditionally seen is they stay as technical debt, because the business functionality and other defects, things like that, tend to get a higher priority over the security issues. So while the goal is that the functionality that that the end users have, whether that's an external customer or an internal, right, the business side of things, yes, that's out there, but it's at risk. And so while those things are all working, but what happens when something goes down or there's a breach or something? We want to work to address those things much, much earlier, right? And continuing on with this, and then what happens is eventually we deploy. So with DevSecOps, we usually have these disparate teams: development, security, and operations, focusing on really application security and infrastructure security. What do we want to do? We need to bring them all together. Now, as we all know, security plays a fundamental role in decreasing risk. And we need to increase the quality and prevent breaches at the same time. Okay, so when we think about that, what are we trying to do? Well, typically, again, what do we see? Development, testing, operations, everything then gets put into security, and then it goes to operations maybe to deploy. That creates a bottleneck. Remember, what we want to do is we want to get things out quickly. So what we want to do is when we shift security left, and as part of the entire development lifecycle, we remove our bottleneck, we now get much, much higher throughput and actually higher quality and higher security. So that means a reduced risk. And that's what we're aiming for with DevSecOps and everything. Now, the thing is that over the last couple of years, especially over the last couple of years, with more and more remote work taking place, we've seen a higher emphasis on security because of breaches and other things. And we've seen that because of that emphasis on that what we really see is a greater emphasis with security into the SDLC with applications and infrastructure. And really the thing is that everybody's moving to trying to be more proactive and have improved security, and thereby, right, folding security into the DevSecOps process, which means it's really, we're no longer at DevOps versus DevSecOps. It's either DevOps with security or it's DevSecOps. And so, and really now that's across all teams. And the important part there is that where that changes is that instead of a single security team really focusing on things that is outside the bounds of the development lifecycle, that security team is working across other teams within the bounds of the development lifecycle. And again, this is how we remove the bottleneck and we get higher throughput. Now, one of the other things too that's important to really look at here is what is the cost of not addressing an issue early on. And so this was done by NIST, and this is about the inadequate software testing. And this is not only about security, but also just general defects and everything. And when this was done a couple of years ago, the software cost was roughly $60 billion annually. Now, this takes into the cost of a software developer to roughly $300 an hour. That is a fully loaded cost and everything. So you could adjust that company, but again, this takes all of that into consideration. But when you look at this, right, when we look at the different phases of the SDLC, when an issue is identified and addressed, and that's the important part. It could be identified early on, but it really matters when it's addressed. And the sooner it's identified, the sooner it has the opportunity to be addressed. But as we can see here, the number of hours and everything that is spent, the impact goes up. So when we're looking at roughly 2.5 hours in kind of that development and coding stage to production, we're now all of a sudden at 13 hours and $720 to roughly $4,000. So it's a pretty big increase. Not to mention the fact that when something is found in production, it's not only the cost, but there's the higher risk. But what else has to take place is that now everything needs to go back to the development and testing stages, and other things may have to have been put on hold to address these things. So again, the sooner that we can identify and address things, the better and more efficient, and actually reduce risk and reduced cost to address the issue. So where do we really want to get to? We want to, sequential DevOps works. It's where just a lot of companies start. It's where a lot of people are, and it's okay. It's a start, but there's still silos. There's still a little bit of friction. There's still a lot of, kind of waiting for permissions. We say finger pointing here, but I don't want it to think where it's like, oh, you did this and this team did this. Really what that is that when identifying an issue, the different teams, or what that really is that it's not clear on kind of whose domain is it in, where it should be addressed. And that's really not where time should be spent and everything. What we really want to get to is concurrent DevOps with security. We're going to be faster. Everybody works together. It's that collaboration. Everybody's empowered to act, that full accountability. We've got security, a little bit more measured and known. Really the premise there is, okay, security issue was identified. It came up. Let's go ahead and address it. Let's just figure out who's going to address it. And then maybe go back and say, how is it that this issue, how did it not come up? Maybe if you've got security scanning, we're going to talk about that and see that a little bit later. Maybe those policies need to be updated. Maybe something was classified as a certain risk, or and it should have been a higher risk, anything like that. But it's about going back and saying, hey, how do we avoid this from happening again? Let's update how we're doing things so that we can get better and better. And that's the thing, it's that continual improvement of the teams working together and really kind of maturing. And that's really important because, one of the big things is that how do you now go and implement security into DevOps and transform them to really using DevSecOps? First and foremost, one of the things that's really important is that security really needs to be seen as being an educator. Right? Security isn't fixing things. Security, really what they're doing is they're aware of threats and they have things at their disposal to scan and find issues, and then they let maybe the app teams or the infrastructure teams, whoever it may be, make them aware of those issues. What they're really trying to do is actually protect the applications that are being written and protect the company. And so the question is how do we get those teams to start to work together? So one of the things that we do is when we're working with customers on their kind of DevOps or DevSecOps journey, we work to establish a common understanding and a set of goals with the development, operations, and security teams. And what we do is we do this through our DevSecOps maturity model. And one of the first things we always like to do is let's figure out the principles that are important, what are some of the practices that are then informed by those principles, and really what are some of the challenges. A lot of times, there's kind of known principles and practices, and what we do is we work to identify the challenges that the customer wants to resolve. And we look at those and we start to prioritize and we break those down into how do we, really what's going to be gained here, why is this important? And this helps us say, okay, here's where we really want to get to. Okay, so what is it specifically about the processes? What are really the important things? And this is something that you don't do once, you just have to kind of come back to it over time. But we always like to start here. And what this then does is it then helps us inform and start to work on the DevSecOps maturity model in this framework. So we base it off 5 dimensions, and across each dimension, there's 4 different levels. So we look at build and deployment, culture and organization, implementation, information gathering, test and verification. What this helps do is that it defines a standard plan and adoption framework for teams. So it really does outline the changes across the SDLC, the tools, and the processes. What this then does is accelerates adoption because we've now created a clear set of expectations to reduce confusion and complexity. So in a nutshell, the way this works is we work with each of the individual teams and together, what's your utopia? What would you really like to see? And then what we do is we say, what are the incremental steps to get there? And then what we do is across all of the dimensions and now those levels, we eventually will get to the end state. And now all the groups have put all this together. And now all of the groups will have a clear roadmap to where to get to, an incremental roadmap. Now, we always start with the dimensions across the 4 levels. And what we have found is that once a company is up and going, they've been doing it for 6, 8, 12 months, they come back and they actually help redefine their levels, because what used to be maybe a level 3 or 4 because of the maturity of the groups is now maybe a level 2 or 3. And that's the great part, is that but they're still all working together as they mature, and that what happens is now the levels mature as well. And what this starts to look like is you can say, okay, the different teams, where are they across these different levels, across these dimensions, and you start to measure this. What's really important about this is, one, it gives a little bit of direction, an agreed upon direction across teams. It also gives a roadmap for the individual teams, the dev teams, ops teams, security, what have you, to work through these. But it also now helps measure the impact, and there's a lot of other metrics too, but it helps measure the impact as teams progress through this. What we typically see is the number of defects go down, the number of releases go up, the time it takes to do a release goes up, the amount of testing goes up, the amount of manual testing goes down, so more testing, reduced manual testing, but overall we see higher test coverage and things like that. And that's a trend that we consistently see with every company we work with. And then what we see is actually more and more features and functionality is getting released in either the same period of time, or let's say over a measured period of time, let's say a year. There's a lot less technical debt, and on and on and on. There's just really just so many benefits that we see consistently across all of the teams that we work with. Okay, so the next piece is we've got that model, but now we need to let's get down a little bit more into brass tacks, if you will. So we all know the SDLC and what's taking place. And we like to think of, there's 2 different types of pipelines. There's the infrastructure is code, configuration is code, and then there's code changes. These things sometimes happen in concert, they sometimes happen separate from each other, but either way, it's about automation and going through different steps to build and deploy applications, provision and configure or retire infrastructure. And depending on the pipeline, then what ends up happening is that throughout the SDLC, we've got different areas, right? Code review, SAST or DAST, penetration testing, software composition analysis, compliance, patching, security, all these sorts of things, right? And the thing is that we a lot of times see a lot of different teams using a lot of different tools. Now, the challenge with this is that everyone is doing it a little bit differently, and there's no sharing of knowledge. There's less reusability. It's really hard to get insight into kind of overall what's taking place. And so the other thing with that is that it makes it very difficult to really kind of define and enforce policies and understand how does everyone measure against those policies. Now, this is not to say that you go in and you force every team to use very specific tools. What this is really about is a lot of times we see lots of different teams are using duplicative tools, and it could be that teams can consolidate. So that's an opportunity there. We definitely don't want to, say, all right, this team is using this tool. Well, now this other team is going to use it. Stop using what you've been using, because you still want some freedom of the different tools. But again, it has to be within kind of reason, because each team, again, using different tools makes it very difficult to enforce standards. Everybody's doing it a little bit differently, again, instead of a standard set of platforms. So what we end up also seeing is, okay, so you've got the SDLC, you've got all these things and these things that take place, but who's responsible for those? What group? If something is found, for instance, during a SAS scan or a code review or patching, let's say, who needs to be alerted? Who needs to be aware of those things, depending on the severity? Does it need to get kind of escalated almost? really starting to think about it and use almost like kind of like a help desk slash operations center really sort of mentality, so that when again issues are identified in different places, the right groups get alerted, and then kind of going through the process to say, okay, this is low risk or this is high risk, and starting to then identify how it gets addressed. Now, the other part of that too then is that responsibility. Then it's going to be, what are the tools that are going to help there? Now, this is not meant to be that it's every tool that should be here, every single one. There are definitely tools and platforms that can do a lot of these things that you'll see here today. So where to start? One, do a cataloging of tools that are being used, understood how each of the different teams are using them, why they chose them, and kind of, again, what's currently being used and what's not being used, with the understanding of, yes, you might move away from some of those tools. And it needs to be understood that, yes, that hard work was put into, let's say the build pipelines and everything else, just like software. But just like software, things change. What it needs to really be about is it's really about making things easier and more comprehensive. And so, yes, some tools may go away and tune for others, but that is just the maturity and right, kind of how we keep moving forward overall. Right? It's not about one team and one team's tool. This is about kind of the larger, if you will, objective and mission. So where do we go from here? Well, you may be asking yourself, how is this related to OpenShift? Okay, well, some of you may know, OpenShift is a tool, it's a platform, and it's a comprehensive container orchestration platform. It is built on the really de facto standard of Kubernetes. And the goal is that it's not just Kubernetes, it brings in a lot of other things that would be used in a environment where you're going to be running workloads on Kubernetes, and it's about getting up and running quickly. And the thing is that it's using a container orchestration platform is really and truly part of DevSecOps. In the way we look at it is because it allows so much more in terms of managing workloads, the build and deployment process, the flexibility and empowering, and also kind of focusing on, instead of keeping servers and things up for applications deployed, you just keep, in this case, OpenShift up and running and everything. It's really becomes the workhorse of where applications are running. And then also now secure, containers and Kubernetes, right? They definitely can be set up in certain ways that create security holes just like anything else. But when we think about what containers and Kubernetes do, they add an extra layer of security to things as well. So that's why it's really part of DevSecOps and everything. But what's really important is that while OpenShift in itself implements security, it's really the DevSecOps activities that take place really before a workload is deployed. So we've got the code review, the SAS, the software composition analysis, and all these other things that take place that really needs to happen, before something is deployed. Now, as you'll see here today, what we're running is we're actually running, for instance, Snyk inside of OpenShift. So Snyk is, and there's a lot of other ones out there as well, is actually a certified Red Hat partner. They're a certified technology partner. What that means is they have, Snyk has really worked with Red Hat to certify Snyk running on OpenShift, which means it adheres to OpenShift's additional security standards. And then it also is kept up to date by Snyk with OpenShift as OpenShift gets updated. So you now start to have this multi-layer support from both Snyk and OpenShift, but now you've got really this full security. And like OpenShift, it is meant to get up and running quickly. So with Snyk now on it too, it right, push a couple buttons and it gets deployed and off you go. And it's about being able to implement things very, very quickly. So again, going back into the DevSecOps, it's about being able to really quickly get a platform up and running very quickly. And so how does this mean that OpenShift enables choice? Well, with Snyk and other platforms, I mean, we can do container scanning and things like that. You'll see that. But Red Hat has also advanced container security for Kubernetes. And they don't say, oh, you have to use this. They allow customers to choose what works best for them. And that's how OpenShift provides choice, because there's no proprietary APIs. There's no proprietary way things have to be run. Uh, it's a platform that is open, and Red Hat says, look, if all these other companies, if you want to run on OpenShift and be certified, we need to make sure that you meet our security standards and protocols, and we will work together to certify that, and also work in a roadmap, if you will, so that the platforms can continue to be deployed and working on OpenShift. So it becomes very much a mutually beneficial partnership. Okay, so what we'll do now is we'll go ahead and hop in, and so we can talk through Sneak, and then we'll go through a couple of other things as we begin to then wrap up here today. Okay, so I've logged into OpenShift, and we're going to look at using Sneak. So one of the ways in which you can install Sneak is through an operator, which honestly is really preferred. It's the easiest way to not only install, but also to really kind of have itself update and keep itself running. So I already have it installed, but let's walk through as if I did not. So if I were to go here and I were to go to choose, and I see that I have Sneak, so I would choose the operator and I would click and I'd go through the install process. Once it has been installed, it'll show up as an install operator. And one of the things that you can do is set up a Sneak monitor, which I can go through here and do that. Now I already have this set up. So I already have one running. Here it is. And so this is now up and running, and it's watching for changes in the environment. Now I've only have one set up here for today, but you can set up different monitors either for a specific project or a namespace. You could do it for a specific application. It's really up to you how you want to do that. But anyways, what they will do is it's going to go ahead and scan and collect information. Now, as that scans and collects information, it will feed it up to Sneak. And so I have an application running, and I'm going to go through the process to show you how I kind of really brings the Sneak monitor and everything together. So what I've done previously is I've actually set up Sneak and I have it connected in. So I'm going to go here to the Sneak dashboard. So I have this up and running. And let's say, for instance, I did not have any sort of project. Now, a project is what are you going to be looking at? So if I were to say I want to add a project, I am then going to choose what type. As you can see, I get a lot of different options, but in this case, I would go to Kubernetes. And in this case, it already knows I've got this because, again, I've hooked this together. And here's one of the namespaces, and I've got two things deployed. I've got Mongo, and I've got this application, this Goof application. I don't need to look at Mongo, but I could. Again, you can see all the different workloads. I can select what I want, and I would select this Goof application. Now, I've already done this, so it already shows up. As you can see right here, you can see this little piece here. Now, you see a bunch of numbers and things here, critical, high, medium, low. These are things that it has found based on the deployment and the container. So when I first deployed this, I was using this container. So if we look at this container, we can see different pieces of information. I can see the tag, the base image is based off node 14.1. I can give it a project owner, and I get some other pieces of information here. Now, this is important, and especially this business criticality, because this allows you to start to catalog and understand the applications. How critical is it, and things like that. We do a lot of things when we're working with customers, whether it's like a cloud modernization or application modernization, or implementing DevSecOps. We always say, okay, let's catalog your applications. And one of the things we look at is complexity, business priority, which is also somewhat business criticality. because that helps us determine the value as we build a roadmap to, again, migrate or modernize or start to fold into the DevSecOps process. So this helps do that. Now, when we look at this image, let's look at a few things. Notice it says recommendations for upgrading the base image. So it knows that, and it's got other upgrade types here. And it is showing us we're at 14.1. Look at all of these numbers. But if we went to 14.2, look what we would automatically reduce down to this. So that tells you just right there how many issues would be addressed just by changing the base image to a newer version of Node. That's very quick change, again, assuming backwards compatibility with Node and everything for the application, but that's a very small change for a massive increase in terms of the reduction in terms of risk, right? We go from critical 51 to 3. So, that's a 93% reduction, give or take. So something that this will tell you about. Now, the other thing is too, is that we start to look into what are all these images all of these issues, and you can start to look at the type and severity and all sorts of other things here, and then it gives a score. So again, it just gives you a lot of this information. Now, this is about the specific container. Okay, so let's go back one. And what I want to do is I want to look at the deployment itself. Okay, this is the deployment itself. And here's the one thing I really want to focus on right here, this configuration. If you look at privileged, it passed CPU limits, memory limits, run as non-root, read-only file system, drop capabilities. What this is about is there's the application in the image, which we just saw, but then this really tells us about, how is it running in OpenShift or in Kubernetes, and how do we go that next step? There's obviously securing the code and everything, but what about the container in the Kubernetes resources as well? So that's another piece to really that's important. So you get kind of two parts to this. Now, when we look at this, one of the things that I had already done is I had already deployed an image, and that's why you now see this image here. So you see this different image, okay? Let's go into this image. Now, I have it as an image tag. So one, it's been imported differently. It's a different image tag. I can see the image ID, all of those things. And if you notice, this base image, I'm not at 14.1, I'm at 14.16. So going from 14.1 to 14.16, I reduced from, what was it, 51 critical to 28, but it's still, again, it's showing me I could still go down to 14.2 and I can still get a reduction. And again, it's showing me all the different types of issues. Now, one of the other things it's showing me is dependencies. Now, what this is that what are the different libraries so the libraries that are being used and what are those libraries using and everything. So it starts to show, the dependencies within the image, where are some of the issues coming from, because it could just be one particular library that can be changed and continue to address issues. And so that's what this gives you insight into. What's important about this is that it really, again, from a security standpoint, it's about informing and educating. From the development standpoint, it's about catching this stuff early and then looking at this and working together to identify what should be addressed and what do we get by making those changes. Again, going from 14.1 to 14.16, we addressed some of those issues, but going to .2, we addressed even more. So we can see, well, that's a pretty quick change. And everything should, be backwards compatible because it's a minor release. But that small change can really drastically reduce the risk profile. And then also looking in here, well, maybe some of these libraries can't actually be changed because it's a library used in another library, things like that. So again, it's the insight to be able to kind of chart a path towards what should be addressed. So I went ahead and ran that. Now, there's another thing that I did. So I ran in the command line. So Sneak has a utility that I can run, and this would be hooked into like a DevOps pipeline. In my instance, I ran it on a code that I had on a server. So think of that as like, let's say a developer and I'm doing development. I did what is known as an infrastructure as code test, and I ran it against some Kubernetes manifest files. What I did is I can get all of those results just locally, but what I also did is I said, well, why don't I go ahead and send them up here um, to this portal. So what I can see is, right, container does not drop default capabilities without privilege escalation, without user root control, all these other things. And then you see here, container has no CPU limit and a number of other things. You see all of these items here directly relate to things that we saw here when we looked at the actual deployment, which is CPU limits, memory limits, and some other things. So if we then go back and we look at this, okay, so again, we don't have some of these limits. So this says, okay, let's go ahead and change that. Now I'm going to go into OpenShift. I'm going to make these changes manually just for today, but really you should probably have these files right in a source control. But let's go ahead and we're going to go ahead and look at our resource limits. Now, this is what it's referring to. So I'm going to go ahead and do CPU is the limit is 250 millicores, and I'm just going to set this to the same. Here, I'm going to save, and automatically a new container is rolling out. Now, what will happen is that it will take a moment, and then it will get updated into sync. So let's go ahead and take a look at how we've now addressed these issues. Okay, so we're looking at the projects. Let's go ahead and take a look, and let's look at our deployment. And now what do we see? We see that our CPU limits and memory limits are now passing, and that is again because we made those changes. So just by doing that, we have now greatly, we've done some additional reduction of, security, but also, you might say, well, wait a minute, just by putting those limits isn't security. What that's really about is, yes, it's not addressing an issue, but it is around managing what's running in the OpenShift cluster. And again, that management, it's very easy. So it's really about, again, that comprehensive piece. And the other thing too is really, again, what are we talking about today? How OpenShift enables DevSecOps platform choice. So, there's other platforms out there that do a lot of the things that Sneak does, and there's some that do different things and things like that, but you have a choice. And as you saw through the operator, that's available, that's certified to run with OpenShift, Sneak, and Red Hat, right? They keep those things together from security and supportability and everything. And you saw, again, very easy to get up and running to be able to implement DevSecOps. And you actually, again, you see how this is running within OpenShift. You are not forced to use just what OpenShift has or anything like that. You have the option to use what's going to work best for your organization. Okay, so we're going to talk about OpenShift and Prisma Cloud. So Prisma Cloud is from Palo Alto, and what it does is it gets deployed into OpenShift, again, using an operator. So very easy to get up and running, get installed, and have it configured, and also really manage itself. Right? That's, again, that whole piece around the operator. The other part too is it's certified to run in OpenShift. So Palo Alto is working with Red Hat to get certified and match the guidelines and everything there for OpenShift. And then also as OpenShift gets updated through its versions and releases, well, the same thing is going to be happening with Prisma Cloud. So again, going back to having both solutions being supported both individually, but then also together with the goal of getting up and running quickly and start to use the scanning and security capabilities that are there. So with Prisma Cloud, we're going to go through some of the features here around using it. Again, all of this runs inside of OpenShift so that developers or security teams can get in and look at what the results are. But then again, it's all running in the same environment and providing that feedback. So one of the things that really the premise around Prisma Cloud is known as defenders. Now, defenders get deployed, and what they're doing is you can have multiple defenders. Is they're really helping scan and do things. So when you deploy Defender, you see that in the Prisma Cloud portal that again hosted in OpenShift, and you can see all the defenders and everything that's going there, and the status and everything that's going on. So that's really the primary piece of what's scanning and doing everything. Now the thing is, so you've got a defender, but really the question is what is running inside of OpenShift? How do you get a good view into that? We really have the ability to look at things as applications and workloads, but if we really dig down a little bit further, how do we see all the connections to things? And that's really important because it's one thing to know what's running, but also what's the interaction between everything. And so that's what Prisma Cloud allows us to do, is that within the console, you can see all these green dots, you can see red and yellow and everything. What that is that as all these workloads are running and communicating with each other, Prisma Cloud is observing that and starting to be able to build connections. Now, let's take, for example, that we have an application that is going to be the first time that it's deployed. So we wouldn't have any connections. There's no network communication, nothing like that. So let's say, for instance, we have this application. We're going to call it the SOC application, okay? And let's say within that, we can place orders for SOCs, but to place an order for a SOC, we're going to be searching for what products there are. As we're searching for products, we're going to be shown things. What are the available sizes and the pricing? And I choose the quantity, and we've got to check to see, is there stock for that? Is something sold out? We put things in the cart, as we all know. People put things in carts, and then they leave, and then they may come back. So how does that update stock and everything, and people coming back, and then they're going to check out. So let's say in this case we've done all of that, and now we've placed some orders and everything there, and so obviously you're going to get some great socks that are going to get shipped to you. Hopefully they're comfortable. Now that we've done all of that, then the question is, okay, what is the interaction between all of those components? So here, what we can see, you can see there's a catalog, and there's a front end, and then there's a user service, then there's a cart service, there's an order service, there's a payment service, shipping, and all these other things. And then you can also see, for instance, database, messaging with RabbitMQ. You can see now that we went through an application and all of these different workloads started talking to each other, Prisma Cloud saw that and brought those things together and now builds this communication map. So that's one piece of what's going on with that. Now, with these workloads, whether you're seeing them talk to each other or not, let's say that you want to dig down a little bit further. So what we can do is we can look into each of these various workloads to really see what is taking place from a security standpoint. So in this case, we're able to look and start to filter by, let's say, different namespaces, different security thresholds. So let's say we wanted to look into those sorts of things. So we can go ahead and do that. So what we want to do is we want to look at shipping, and we're going to get some more information about that because we see that there's a risk with shipping. So if we click on shipping, well, a couple of things now we can start to see. One, what's the image? What's the ID? And that's to ensure, do we have an image with a new SHA that is the newer version? Is it an older version? Is there a newer version, the one that should be deployed? Right? It gives us that insight so that we know what's in the environment. We can see things around what's the OS that's in the container, what's the version of that, and some other things. Where is it deployed? How many containers, things like that. And then what we can do is get some more information. You can see here with vulnerabilities, we can look at compliance and different layers and things, but we can dig down into this specific container to see kind of, what is creating that individual workload's risk profile. And in this case, we can see there's a critical CVE that we probably want to have updated. So we could go through and update that and see what the impact is. And we could go through and keep doing that and again, beginning to address the security risk and starting to reduce that really one workload at a time. And within a workload, what are the different components? It could be the base image, it could be a library that's being used within that base image, whatever it may be, right? We want to get that information so we can identify what exactly needs to be done to reduce the risk, and then what is the expected impact in terms of a risk reduction every time we address one of those items. Now, let's say we wanted to see some other information. So we look at Mongo, for instance, and what we're doing here is we really want to look at the vulnerabilities a little bit further. So we're going to look at, in this case, we're going to switch to a different container. We're going to look at Mongo. And so what we see here is Prisma Cloud is saying we're learning more about this container. It's brand new, so it's collecting information and learning more. But as you can see, again, we get the ID, the namespace, when was it created, and other pieces of information. And this is really important because what we're starting to do now is we're getting more into the runtime security and the container runtime, right? So now that there's always that build and release process, that's important. But now we're getting into as a container is actually running, what insight can we get? Because there's different phases to a container. There's the build, and then there's also the run and operate piece. So here, what we're doing is we're looking at this, we're getting some information, and if we were to look at, let's say, the processes tab, some of the things that we can see, for instance, is we would be able to see what processes are running, any certain behavior, things like that. We can see networking in terms of ports and other things. And we can really dig in to see more information about this container. What's important there is, yes, you can go see this stuff from OpenShift, but yet you can also see it here in another view. And again, it's so that you might have one team, let's say developers, maybe they're going to be in OpenShift, or operations will be in OpenShift, but security may be here. So it's different views to get to the different pieces of information. Now, when we look at everything, as you can see what I'm showing here, as we talk about the container runtime, that's when things are running. But beforehand, and actually while things are running, what do we need to do? We need to be thinking about compliance and thinking about malware, right? That's how we try to get as much as we can proactive in identifying things as soon as possible when it comes to potential breaches or things that are running that can really cause havoc. But then there's also compliance. We have customers, some of them have to be have PCI, some of them have HIPAA. There's a lot of different things that have to be done. And then we have a number of customers too that they just have their own internal policies in terms of security. So you want to be able to say, where are we at from a compliance standpoint, in understanding how do we measure up to that, and what needs to be done to get into our compliance. So you might have, for instance, different levels of CIS scanning that's done, right? That could be CIS against, let's say, Linux. It could be against Kubernetes. It could be things around containers like, Docker or CRI, things like that. You want to understand, again, what's the compliance rating, and what's important here is with the different types of compliance is that it's really different at different layers. Again, you can have it at the OS, which is that Linux layer. You could have it Kubernetes, which is OpenShift, right? That's at that orchestration and platform layer. And then you can have it down at the Docker part, which is what's running in Kubernetes, which is running on the infrastructure. So it's at different levels so that you can make sure that you're not kind of looking at one specific area to address things while forgetting about another. It's really about comprehensive security. And so getting a dashboard of all this information so that, again, the different groups that are focused on different areas, who are then, again, being educated from this standpoint, from a security standpoint, can go and look at what's going on and figure out how to address it, and again, make that incremental improvement with all of that. Again, looking at this, we start to look into, again, different vulnerabilities. So we can see here, for instance, all the images that are deployed, and we want to see for all these images, what are the various vulnerabilities, and we can start to really rank and see which ones are really causing the problems. Because it might be that if there's an image that's used over and over and over again for different workloads, that if you update that image and address it, and then roll that out to all of the workloads, a small fix, but it's kind of done rinse and repeat, now drastically reducing security vulnerabilities. Again, it's always a trade-off of understanding what's the level of risk and what does it take to address it, and then looking at it from the standpoint of what can be done with really what's the level of effort to, and what's the maximum outcome. And to be able to do that, you have to drill down to different layers and get all of that information. Now, one more thing that we'll get into here is also part of runtime, which is known as attack. So, and it's attack not in the traditional sense, it's ATT, the at symbol or the and symbol, CK, so attack. And what that is that is within Prisma Cloud, what it provides is it's a knowledge base of tactics and techniques that, if you will, adversaries use to attack applications and infrastructure. And what it's for is that it's a framework that is really meant for building a threat-informed defense, where a deep understanding of kind of what these adversaries are going to do, by understanding that behavior and their tactics, you can then have defensive ways to fend off those attacks and do things preemptively. And the thing is we all know with security is that it is a constant thing. They're going to, as techniques are formed to run defense against attacks, there's going to be different types of attacks. So it's this constant thing, and that's what Prisma Cloud offers. Here is this attack piece, and you can see here that it's this dashboard provides a lot of different ways into, for instance, initial access or execution or things, let's say, around persistence or privilege escalation and things there. So based on really these areas, these different pieces of behavior, you can look at and say, well, how many areas am I impacted, and what's the level of impact, and what are the things within that area? So for instance, privilege escalation. There could be that there's exploitation for privilege escalation, or let's say there's a privilege container, or there's writable volumes. Well, if those specific types of events are outlined, you can go and look and figure out, well, where is that taking place? And again, it's this additional step of scanning and that forethought to say, hey, this should probably be addressed because this might be an area where somebody trying to get into the system, this is an area that they're going to exploit. So when we think about a lot of times CVEs, we think about those security issues that, there's been code that's been fixed, and then there's also best practices around, containers, things like that, and compliance scanning. And you do all of those things, and those things help, and those help protect against attackers. But the other part too is, what are attackers going to do? And that's what this attack portal does. So again, with Prisma Cloud, it can be deployed in OpenShift via an operator. Everything runs. It scans the workloads. You deploy new workloads and start using them. It's going to be building that you saw that kind of that graph. That's the radar, and then it's using the defenders to monitor everything. And then you're able to drill down and look at images and components and everything there that's taking place to address those vulnerabilities. But then the next piece around that is getting ahead of what are common ways in which applications and infrastructure can be exploited, and how to address that, where to go address that. Again, it's all about informing dev teams and operations teams where there are security issues that have been identified, right? That's the education piece. And then allowing those teams to understand those things early and address them early, and then tracking that. So tracking that security posture over time. The other piece too is, let's say something does happen. There is an exploit, whatever it may be. Sometimes things happen, but now armed with this information, you can see and look at and very quickly identify everywhere that this fix needs to be deployed, and then track as a fix gets deployed again, whether that's a CVE or some other configuration. Well, so as we've seen here today, a couple of different ways in which you can implement DevSecOps with OpenShift, right? Therefore demonstrating the choice that OpenShift provides. And so one of the things, again, there's a lot of technologies that you can choose from. There's technologies that are certified to run on OpenShift, and that is really, again, making it so that it is very easy to get up and running and knowing that you're going to have a secure and stable DevSecOps platform within a secure and stable container orchestration platform, which is OpenShift. And again, the openness and how OpenShift enables that choice is demonstrated through the fact that, again, you have choices, but also even Red Hat has advanced cluster security for Kubernetes, which does the container scan in the different phases. And you don't have to use that. And there's no proprietary way. You have the choice based on what you need. So in wrapping up, quote that I love from a guide from the FTC around starting with security. And they say that companies that consider security from the start assess their options and make reasonable choices based on the nature of their business and the sensitivity of the information involved. Threats to data may transform over time, but the fundamentals of sound security remain constant. What's really important about that is you got to start somewhere. You got to do what's right within an organization and what your needs are. That's where the maturity model comes into play and how that's going to evolve over time. And so with that said, if you are starting your DevSecOps or DevOps journey and you're looking for someone with a lot of expertise and experience to really help either build a strategy or to help you implement a strategy, that's what our experts are here to do and to help with and to help do that quickly. You can reach out to us at hello@excelino.io or through our website or our social platforms like LinkedIn and Twitter. So again, thank you for joining our webinar today around Red Hat OpenShift and enabling DevSecOps platform choice. Again, if you aren't following us already, feel free to follow us on LinkedIn and Twitter. And that way you can get information as we publish that out based on our thoughts, trends, things like that, and additional upcoming webinars. Again, this webinar will be available on our YouTube channel here soon. So if you'd like to come back to it, definitely feel free to watch that again. It was great having you all here, and I look forward to hearing from you, and we're potentially seeing you in our next webinar.